Another property that the operations on real numbers have is this identity property that we don't talk about very much, but when we need it, we really need it. So the additive identity property says there is an additive identity which happens to be 0, such that for any real number a plus 0 is 0 plus a is just a. Adding 0 doesn't do anything. That's the additive identity property. There's also one for multiplication. The multiplicative identity happens to be the number 1, right? Multiplying by 1 doesn't do anything. That's the multiplicative identity property. Is there an identity for this operation, composition of functions? Again, yes, there is. There is an identity function such that for any function, if we compose it with the identity, we get the original function back. Notice that addition and multiplication are commutative, so we didn't actually have to mention both of these or both of these. But composition is not commutative, so we did have to mention both of those separately. What is this identity function? Right, we call it little id, id for identity, and it's the function that doesn't do anything. Whatever input you give it, it just gives that input back as output. Right, and it's easy to see that that's not going to change anything in composition. If we take f composed with the identity, right, well, that's just f of the identity of x, which is just f of x. On the other hand, if we take the identity composed with f, that's just the identity applied to f of x. What does the identity do? It takes its input and gives it back. So again, that's just f of x. So with this definition, this really functions as an identity function. Now, this is possibly the most singularly boring function you could ever hope to see. But the reason we want to mention this is that in the next video, we're going to talk about the inverse, and then this is going to become useful.